First problem of this sheet, basic illustration, is about a particle hanging, particle let's say of mass m hanging, string of length L, and is imparted a horizontal velocity root GL. Find the speed of the particle when the tension becomes equal to the weight of the particle, right? So tension is varying and we want to be able to find the speed of the particle when tension becomes equal to the weight. Say when the angle becomes theta, angular displacement becomes theta, tension T becomes equal to the weight, and let's say velocity becomes V theta mg. Simple stuff. We want to be able to find the V at this angle when tension becomes mg, right? So this amount of elevation, right? So half mu squared that the particle was imparted appeared partially as half mv squared and gain of potential energy. Yes or no? Right? Which means V squared is u squared minus 2gl into 1 minus cos theta. That's preserving energy, right? And then centripetal force requirement here, T minus mg cos theta is mv squared by L, right? T, which is mg minus mg cos theta, is mv squared by L. Yes or no? Now, what do we need to solve for? We need to solve for, there are two unknowns, V and theta, Very clearly, u squared is GL, so V squared can be written as GL minus 2GL into 1 minus cos theta from this equation. U squared is GL, so GL minus 2GL into 1 minus cos theta, which is essentially GL into 2 cos theta minus 1. 2 cos theta minus 1, how about it? Right? That's V squared, which we can plug into this, V squared by L, right? M of course gets cancelled. So G minus G cos theta is V squared by L. V squared by L is G into 2 cos theta minus 1. G of course gets cancelled. That gives me cos theta 2 cos 3 cos theta equals 2, or cos theta equals 2 by 3. At cos theta equal to 2 by 3, T becomes equal to mg. I need to find V. So plug in cos theta is 2 by 3 here. So plugging in cos theta is 2 by 3, GL into 4 by 3 minus 1, that makes it 1 by 3, right? So that makes V equal to root GL by 3. So when the tension becomes equal to mg, the velocity of the particle becomes equal to root GL by 3. I expected you to get this right. Did you get it right independently also? Very good. Can I wipe this off? Number 2. There is a 40 kg mass hanging at the end of a rope We'll assume light inextensible rope of length L, which oscillates in a vertical plane with maximum angular displacement being theta naught, right? Theta naught is the maximum angular displacement. That means when theta becomes theta naught, velocity would have become 0. That's the amplitude. That's the amplitude, right? What is the tension in the rope when it makes an angle theta with the vertical? You know, while journeying from A to B, which is its amplitude, it will acquire a position theta, right? And we wish to find the tension in the string at this position. Wish to find the tension in the string in this position. 1. 2. If the breaking strength of the rope is 80 kilogram force, what is the maximum permissible value of theta naught? We'll address that later on. First of all, let's find the tension in the string when the angle becomes theta. Okay. Very simple. While going from B back to A, it would have acquired a velocity v at this theta, right? It would have acquired a velocity v at this theta. That means between B and this position P, it gains kinetic energy. It gains kinetic energy. How much of kinetic energy does it gain? Half mv squared. Why? Because it has lost potential energy. It has lost potential energy. Now, potential energy is about loss of elevation. See, at some theta, when this angle is alpha, say, then the elevation from the base, let's say this is the base A, this is L cos alpha, right? And the elevation is L minus L cos alpha, right? This is L minus L cos alpha is the elevation from this point for any angular displacement alpha. Okay. What's the elevation for B? Starting from A? L into 1 minus cos theta naught. That's the elevation for B, right? Elevation for P, H2, is L into 1 minus cos theta. There is loss in elevation. Loss in elevation is H1 minus H2, right? What is loss in elevation between B and P? Delta H, which is initial elevation which is higher, final elevation which is lower, H1 minus H2. Yes or no? Right? Which is L into cos theta minus cos theta naught. Yes or no? That's a loss in elevation when you go from B to P. Therefore, loss of potential energy would be mg into loss of elevation. So, gain in kinetic energy is loss of potential energy mg into delta H, which is L into cos theta minus cos theta naught. Clear? Now, come to the tension at P, which is what we are seeking to find. T is the tension. This angle is theta. Like before, T minus mg cos theta would be mv squared by L, right? So this is energy compliance, force equation, centripetal equation. T minus mg cos theta is mv squared by L, right? mv squared by L, as you can see, is 2 mg into cos theta minus cos theta naught. Yes or no? mv squared by L is 2 mg into cos theta minus cos theta naught. T then becomes transposing mg into 3 cos theta minus 2 cos theta naught. That's tension as a function of theta, right? Clear? Now, if the breaking strength of the rope is 80 kilogram force, That means 80 into 10 newtons. What is the maximum permissible value of theta naught, right? Okay. Now for a given theta naught, tension would be maximum when cos theta would be maximum. What is the maximum value of cos theta? 1. 1, right? Right? So T max for a given theta naught, T max would occur when theta is 0. Theta is 0 means when the rope is in the vertical state, that's theta equal to 0. When the rope is in the vertical state, tension will become maximum. That is when theta is 0, cos theta is maximum. T max is mg into 3 minus 2 cos theta naught. Right? And if the breaking strength of the rope is 80 kilogram force, and you want it to withstand the tension at all points. See, if it can withstand the tension here, which is the maximum, then at all other points tension will be less than T max. It will be able to withstand the tension everywhere else. See, this is the most vulnerable state where tension is maximum. So if it doesn't break here, it will not break anywhere else. Yes or no? Isn't it? Huh? That means if the maximum tension itself, which is in the vertical state, is 40 or how much? 80 kilogram force, which is 800 newtons, say 80 G, then the tension everywhere else will be less than 80 G, and therefore it will not break anywhere. Now, so this gives me, see, G gets cancelled. M is how much? 40. So this will become 2. Cos theta naught is half, or theta naught must be 60 degrees. So if the amplitude is 60 degrees, then it will be able to withstand. So a maximum of 60 degrees of amplitude is permissible, so that the breaking strength does not cause the rope to snap. Clear? A small body of mass m is placed on top of a smooth surface, spherical surface of radius r, which is fixed. This is a smooth spherical surface which is fixed. This is the center O, r is the radius of this surface, and there is a mass m at the topmost point of the surface, and the surface is given to be smooth. Now the particle is at rest here, and it's slightly pushed so that it will begin to descend along the surface of the sphere. We want to find the position where it loses contact. Angular displacement from the vertical where it loses contact is what we are seeking to find. Clear? Now, in general, after it has descended an angle theta, say it would have acquired a velocity v, right? Force is acting on it. It's resting on the surface of the sphere. So the sphere will exert a pushing force on it, normal reaction n outwards, right? In a very general sense. There is going to be mg downwards. This angle will be theta, right? First things first, it has lost elevation, this amount of elevation. So there is loss of potential energy, which comes out of, which goes into gain of kinetic energy. It is at rest here. It gains how much of kinetic energy? Half mv squared. Half mv squared is what it gathers, and that's because it has lost mg into this height, right? When it goes from this state to this state, this is the elevation that it loses. How much is this? This is r. See, this is r. So how much is this? R cos theta. So this length is going to be r minus r cos theta, which is delta h, the loss of elevation accounting for loss of potential energy. So mg into this length, which is r minus r cos theta. That's energy compliance. Now centripetal force requirement, it's moving in a particle is moving in a circle of radius r, right? Now, at this point, how much of centripetal force does it require? It requires mv squared by r is what it requires. And who gives it this centripetal force? No, mg cos theta minus n. Mg cos theta minus n, right? The force directed towards O. Now, see, at some point P, when it loses contact, in mechanics, what qualifies loss of contact? N becoming 0. Right? The state where N becomes 0 is a state where there is loss of contact, right? So, let's say at this theta it loses contact, right? Loss of contact is given by N equal to 0, right? That means mv squared by r is provided by only the component of weight in this direction, mg cos theta. And again you can see mv squared by r from here is 2mg into 1 minus cos theta, eliminating v. mv squared by r is 2mg into 1 minus cos theta, which I can substitute here, right? 2mg into 1 minus cos theta is mg cos theta. Mg gets dispensed, or we have 3 cos theta is 2, or cos theta is 2 by 3. If at theta equal to cos inverse 2 by 3, there is loss of contact. At cos inverse theta equal to cos inverse 2 by 3, there is loss of contact. A more interesting part of this problem we will handle most likely in the next class, where I say that even though the sphere is smooth, it is not fixed. The sphere is capable of moving. The sphere is capable of moving. And when I say that, I'm again seeking to find the new angle theta where there would be prospective loss of contact, right? That would be a little more involved and challenging situation to examine. In which there is a particle suspended from a point OA. OA is length L. And it's projected horizontally with a velocity v such that after the string becomes slack, it flies through the initial position, that is A. Now, if you recall our discussion from the previous class, okay, it would want to undergo a circular path like this, right? And in the first quarter of the circle, there is no prospect for tension to become 0. It's only in the second quarter of the circle that you can have, it's in this quarter of the circle that you can have 0 tension. And say, at some point here, on this circle, on the second quarter of the circle, tension becomes 0. At B, tension becomes 0. Now, say, and once the tension becomes 0, the string will slacken at this point. It will then be at the mercy of gravity. It will then follow a projectile, right? At this point, let's say the particle would have acquired, by the time it reaches B, it would have acquired a velocity v1, which would be perpendicular to the radius, because up to this point, it has been a circular trajectory. So this is the trigger point where the string slackens and the particle would be solely at the mercy of gravity. Now, say this happens at some theta. At this point, that is B is given by this theta. Okay. At this point, the particle has a vertical component of the velocity, right? If the radius makes with the horizontal an angle theta, perpendicular to the radius would make with the vertical an angle theta, right? So there is a vertical component of the velocity, which is v1 cos theta, and there is v1 sin theta. Yes or no? And there is Mother Earth mg acting on the particle like this at B. Yes or no? What? Now, what they say is, the particle under the influence of this passes through A. A is a point through which the particle passes. This length is L, right? When it goes from B to A, what is its horizontal displacement? This L cos theta, right? When it goes from B to A, its horizontal displacement is this, yes or no? This is its horizontal displacement between B and A, L cos theta, right? When it's at B versus when it's at A, this is the horizontal displacement, which is L cos theta, right? What causes L cos theta? V1 sin theta acting for time t. Isn't it? Horizontal velocity will cause horizontal displacement. So V1 sin theta acting for t seconds will cause the particle to, let's say, to pass the original point A, right? So the time it takes to pass A is L cos theta covered at the rate of V1 sin theta meters per second. Yes or no? Now in this time, what is its vertical descent? Its vertical descent is this length plus this length. Its vertical displacement, see this length B to D, say for example, is L sin theta. Let me take downward positive and upward negative. So when it goes from B to A, what is its total downward displacement? L sin theta plus L. Yes or no? Its total vertical displacement is, downward displacement is L plus L sin theta. No. So L plus L sin theta in t seconds, with initial vertical velocity V1 cos theta. So vertical means minus V1 cos theta into t plus half of gt squared. Yes or no? Tell me. I have applied S equal to ut plus half at squared in the vertical direction, taking downward positive, upward negative. Tell me, so far so good? So this is like L into 1 plus sine theta. Let me eliminate t, right? T is L cos theta by V1 sin theta. So this is like minus V1 cos theta into t. T is L cos theta by V1 sin theta, right? T is L cos theta by V1 sin theta plus half of G into t squared. T squared is this, which is L cos theta divided by V1 sin theta whole square. Yes or no? Now the velocity acquired at that point is V1, right? At this point, this is the angle theta, this is mg downwards, right? And it has a velocity V1 at this instant. Tension is 0, but it still requires centripetal force. It still requires centripetal force. How much is the centripetal force that it requires? mv1 squared by L. And who will provide it the centripetal force at B? mg sine theta, isn't it? mg sine theta, isn't it? Component, because t is 0, otherwise it would have been t plus mg sine theta. So this is mg sine theta. T has become 0. Right? Okay. This is as far as the physics of the problem is concerned. Now let's deal with the messy looking algebra. Okay? That's also part and parcel of a problem solver's domain. Let's deal with things. This is one. This is the other one. Very clearly, V1 squared is GL sine theta. V1 is an intermediate product, and I don't want to be able to deal with it. I don't want to deal with it. No issues. This V1 anyway is taken care of. There is a V1 squared here, right, which I can replace by GL sine theta. Clear? I'll remove the figure for a little while. When required, I will redraw it. This L. So I'm dealing with this equation. So 1 plus sine theta is, see, I've cancelled 1L, 1L. This is cos square theta by sine theta. Sine theta. Then 1L will get cancelled here. So plus half GL cos square theta by V1 squared sine square theta. Yes or no? But V1 squared by GL is sine theta. So V1, see, this V1 squared I can replace by GL sine theta. So once I replace this V1 squared by GL sine theta obtained from centripetal considerations, then GL will get cancelled and this will become sine cube theta, right? So this will get cancelled and this will become sine cube theta. Oh God, that should be the first reaction. I need this theta, somehow. Very desperate. And I have all kinds of cubic and stuff coming my way. But be intrepid, fearless. Let's proceed. What's there? In the worst case scenario, we'll not be able to solve it. Okay. Let's see if we can solve for theta from this. As of now, it looks very, very ugly. That's okay. One thing that I can see, without doing too much of hanky-panky, if I bring this here, then this will become sine square theta plus cos square theta 1 by sine theta. Let me at least do that. If I transpose this on this side, then sine theta plus cos square theta by sine theta would be sine square theta plus cos square theta by sine theta in the first place. Let's at least do that much. And then wait for magic to happen. Nature should help us out somewhere. 1 plus 1 by sine theta is half of cos square theta by sine cube theta. Let me multiply throughout by sine cube theta. One minus sine square theta. This cos square theta, just to bring about homogeneity in looks, this cos square theta I write as 1 minus sine square theta. Good Lord. Cubic and sine theta to solve. Hurting, no? Try. What is there? Let me break this into 2 sine square theta plus sine square theta, right? Then 2 sine square theta into sine theta plus 1, right? This I wrote as 2 sine square theta plus sine square theta. So 2 sine square theta comes here. The other sine square theta will go there. So plus sine square theta minus 1. Yes or no? That's equal to 0 now. I feel a little happy because sine theta plus 1 is a common factor, right? And then inside the parenthesis, I have like a 2 sine square theta plus sine theta minus 1. This I can factorize 1 plus 8, 9. So I can factorize this. Sine theta plus 1 into 2 sine theta minus 1 into sine theta plus 1. Yes or no? This gives me sine theta plus 1 whole square into 2 sine theta minus 1 equal to 0. Sine theta can't be minus 1 because it's the second quarter of the circle that I'm talking of. So theta must lie in the second quadrant. So this is not 0. So sine theta must be half. Theta therefore must be 30 degrees. Which one? After this or before this? Sine theta plus 1 can't be 0 because theta lies in the second quadrant. Refer to the figure. In the second quarter of the circle, therefore theta second quadrant, sine theta is positive. So this can't be, so this must be 0. So sine theta must be half. Theta must be 30 degrees. Right? Once I know this, then I know V1. The velocity point where it becomes a free bird. Right? What result did I get for V1 squared? Can you just tell me? Yes? GL sine theta. GL sine theta, which is GL by 2. So V1 is root GL by 2. V1 therefore will be root GL by 2. I need to find the velocity at the bottommost point V. Then between the bottommost point and this theta, I am going to apply energy conservation to get the value of V at the bottom, right? See, this is how it was. At the bottommost point, I gave it a velocity V, which is what I am seeking to find. At this theta, it had a velocity V1, which we have found, right? Yes or no? Therefore, this length is L between state A and state B. We started with half mv squared. At this point, it became half mv1 squared plus potential energy became L plus L cos theta. L plus L cos theta, yes or no? This is L plus L cos theta. That's the gain in elevation. So mg into L into 1 plus cos theta. Yes or no? V squared therefore would be 2v1 squared plus 2gl into 1 plus sine theta. Sorry, this is L sine theta. Sorry, L sine theta. 1 plus sine theta. That's a gain in elevation. That's a gain in elevation. L plus L. So 2gl into 1 plus 3 by 1 plus half. That means 3 by 2. And 2v1 squared is gl. And there is a 2v1 squared is gl plus 3gl. GL by 2. Oh, there is, oh sorry, this 2 won't be there. So this will be GL by 2. Right? So that makes it 7GL by 2. That's V square. V then must be root 7GL by 2. Velocity at the bottommost point must be root 7gl by 2. So that at theta equal to 30 degrees, when it loses contact and flies off free from the string, it will pass through the original point A as projectile.